Hi everyone, Ravi this side. Welcome to Engineering Adda. Today in this video, we are going to discuss about the encryption and decryption and how we can perform the encryption and decryption in our Spring Boot application. So what we are going to do is, in this video, we are going to discuss about the encryption and decryption, and in the upcoming video, we'll try to see how we can really implement encryption and decryption in a Spring Boot application through developing some real-time APIs. So that is what we are going to cover in this video. So let's get started for that, and let me try to go to the next slide. So here comes the introduction, and let me try to tell you that encryption and decryption are fundamental concepts in the realm of information security, used to protect sensitive data from unauthorized access or interception. Okay, so encryption and decryption are the fundamental concept of information security. They help us in protecting the sensitive data from the unauthorized access or from the unauthorized persons. Okay, so what we are doing in encryption and decryption is, let's say we have developed one API, and that API is giving some response, and you don't want to display that response to some unauthorized person. So in that case, what you will do, you will try to encrypt out that response, and then when you will encrypt it, only the person with the decryption access can decrypt out that message and then see the things. So the person who is not authorized cannot see those messages. So this is what encryption and decryption is. Now let me try to go to the next slide and discuss about the encryption in details here. So encryption is the process of converting plain text or normal readable data into ciphertext, or you can say encoded data, using an algorithm and a key. Okay, so it is a process of converting the plain text or human readable data into the ciphertext, which is the encoded data, using an algorithm and the key. The resulting ciphertext is essentially gibberish without the corresponding decryption key. So if you don't have any decryption key for that particular encrypted message, you cannot decrypt out and you cannot get the information out of that encrypted data. Okay, encryption ensures that even if an unauthorized person gains access to the encrypted data, they cannot understand it without the decryption key. Okay, so this is what encryption is. Now there are two types of encryption. The first one is symmetric encryption and the second one is asymmetric encryption. So let me try to tell you one of symmetric and asymmetric one by one. Okay, so in symmetric encryption, the same key is used for the encryption as well as decryption. Okay, so let's say you want to perform a symmetric encryption, then in that case, you should have one key. With that particular key, you will try to encrypt the message, and with that particular key only, you will try to decrypt that message. Okay, the sender and the recipient must both possess the same secret key. This type of encryption is generally faster and more efficient, but requires a secure method for sharing the secret key. Okay, so this is about the symmetric encryption. In the symmetric encryption, we have only one key which is shared among the sender and the receiver. You can see the person who is encrypting out the message and the person who is decrypting out the message. They both have the same key, and this is what called symmetric encryption. So in the asymmetric encryption, you can get from the symmetric encryption that in the symmetric encryption we have one key which is shared among the encryptor and decryptor, but this is not the case in asymmetric encryption. In the asymmetric encryption we have the pairs of key. You can call public key and the private key. With the help of public key, the encryptor going to encrypt the data, and with the help of private key, the decryptor is going to decrypt the data. Okay, so asymmetric encryption uses a pair of keys, a public key and the private key. The public key is freely distributed and used for encryption, while the private key is kept secret and used for decryption. Messages encrypted with the public key can only be decrypted with the corresponding private key. This eliminates the need for a secure key exchange, but is generally slower and more computationally intensive than the symmetric key. So this is one of the disadvantages of asymmetric key, but it is very much secure than the symmetric key. Now let me try to go to the next slide, and here you can see the symmetric key. We have the plain text, and then With the help of the secret key, we are encrypting out that plain text into the cipher text, or you can say encrypted text. And then with the same symmetric key, we are decrypting out the message and getting back the plain text. So you can see that in the symmetric key, we have the same secret for encryption as well as decryption. Now coming to the asymmetric, you can see that the sender is trying to encrypt the plain text with the public key and then share that encrypted text to the decryptor, and the decryptor has the private key, and then it tried to decrypt out that message and then get the plain text. So this is about the asymmetric key. In the asymmetric key, we have two keys, or you can say the pair of keys, public key and the private key. With the public key, we try to encrypt out the message. With the private key, we try to decrypt out the message. Now coming to the next slide, here is the decryption. Decryption is the process, is the reverse process of encryption. It involves converting the cipher text back into the plain text using the decryption key. Without the correct key, decrypting the data is virtually impossible. So when we are going to do a decryption, we should have a correct key to decrypt out the message. Now let me try to go to the next slide and discuss about the process of encryption and decryption here. So from the things that we have discussed earlier, you could get that what encryption and decryption is. And here let me try to give you a brief example of the process involved in the encryption and decryption. The process of encryption and decryption follows these general steps. The first one is key generation. Depending on the encryption schemes, keys are generated either as a single shared secret, which is symmetric encryption, or a pair of public and private key, which is asymmetric encryption. So the key generation should be done. After that, we are going to encrypt out the plain text, and then the third step would be transmission or storage of the encrypted data, and then the fourth stage is decryption of the data. So first of all, we'll try to generate the key, encrypt the plain text, send that to the decryptor, and then decryptor decrypts that plain text. So this is the whole process of encryption and decryption. And let me try to go to the next slide and discuss about the summary here. So here let me try to brief you about, in summary, about the encryption and decryption. So encryption and decryption are crucial for ensuring the confidentiality, integrity, authenticity of the sensitive information in various contexts, including communication, data storage, and online transaction. They form the backbone of modern cybersecurity practices, safeguarding the information against the unauthorized access and malicious attack. So this is about the encryption and decryption. Now, in the upcoming video, we'll try to first discuss about the symmetric encryption and then its advantage. And after that, we'll try to practically create a Spring Boot application. Then we'll try to see how we can do a symmetric encryption in a Spring Boot application. And after that, we'll try to discuss about the asymmetric encryption, and then we'll try to practically create a Spring Boot application for the asymmetric encryption as well. And there we'll try to see how we can carry out the asymmetric encryption in a Spring Boot application. So these are the videos, and this is about this particular video. If you like the video, please hit the like button and please subscribe the channel for more such content. Thanks.